Hi everyone, I hope you're doing well today. We've got yet another Unity deep dive with Fouad. We're just gonna have a quick recap on what we did last time and then move forward with what we have to do this time. Yalla Fouad, all yours.
Hi everyone, I hope you're doing well. So this is the second session of the Unity Deep Dives. Um, so first of all, let's just quickly recap what we did last time. We learned about scenes, game objects, and components, the basic building blocks uh, of Unity stuff, basically. We learned how to create 2D levels using tile maps, and how to have different tile maps do different things. And we also learned how to create a very simple character controller uh, that just takes our inputs and moves our character around and flips them around and whatnot. Uh, this session, we're going to go over a lot of stuff. So it's probably going to be a bit longer, hopefully not too long. We're going to learn how to control a camera so that it keeps following our player. And we're going to do this using a handy package that Unity provides for us called Cinemachine. We're going to learn how to um, create animations and trigger them from codes so that they play, so the appropriate animation plays. We're going to learn about triggers and colliders uh, and the difference between the two, what prefabs are and why we use them, and how to create simple user interfaces, basic stuff, like a menu and simple HUDs to display the health of our player. And finally, we're going to very quickly go over how to make a build, which we'll learn what that is later on, and how to use GitHub for our projects and why that is important. So, without further ado, let's get into it. I'm going to go to our project here. Hope everybody can see it. Uh, okay, so first of all, you can see if I play, we have a character, he moves around, flips around, that's nice. But right now the camera is completely static and we don't want that. We want it to move with our player. So let's do that. You could theoretically go and code your own camera script so that it keeps following the player. And there's like many ways to do that, but we don't have to do that because uh, we can actually get a package that will do it for us. So we're going to go to Window, Package Manager, and we're going to click here in Packages, go to Unity Registry so that we can look through all the Unity packages. And we're going to look for Cinemachine. Come on, Internet, don't fail me now. There it is. Cinemachine, smart camera tools for passionate creators. So this is a package. I'm gonna hit install. Um, oh my God, it just appeared, the E. That was a bit weird. So Cinemachine is, it's a very, very handy camera tool that is very powerful and will allow us to do a bunch of stuff with our camera, including having it follow our player. Just gonna wait for it to import and compile the scripts. Should be almost done. Okay, there you go. Let's close the package manager. Okay, so now if you go into our project and go under packages, you can see it's actually added this Cinemachine folder down here. But we're not gonna mess with that. What we're going to do is go to our hierarchy and right click, go to Cinemachine and hit 2D camera because we're doing a 2D game. This is what we want. So it's going to create a couple of things. This CM VCAM, which stands for Virtual Camera 1, and it has this Cinemachine Virtual Camera components on it. And this is basically, this will actually control the main camera. So this is the actual, this main camera is still the actual camera that is, you know, if we move it around, you can see here in this little, actually I can't move it around now. That's okay. This is the camera that is rendering the scene to the game view, basically. And it's, as you can see, it's also created on our main camera, the Cinemachine Brain component. So this will just allow the virtual camera to communicate and control the main camera. We're not going to get into the details on what these components do. We're just going to stick to what we need to know for now. And in my slides, I've left some links to the packages if you would like to know more about how these things function in detail. So let's see. We want our camera to follow our player. So if we look here at our components, we have a couple of things. Mainly, we have a follow and a look at parameters. And they both take a transform component. Right now, they're empty. So these are self-explanatory. They're just going to allow our camera to follow and look at a transform, which for us, we want it to be our player character. So as we see here, as soon as I put it on follow, you see the camera snapped, and we'll set the player character to look at. And if we go and hit play now, we can see, voila, our camera is following our player character. And we can actually, and right now, whenever we want to, like, you know, edit anything for this camera, we usually do it in this virtual camera component. So this orthogonal size, which just allows us to determine the size of our camera. I'm actually going to set it to 8. And let's see. If we click here, actually, on this body, and we open it, we get a bunch of gizmos, so a bunch of things that are drawn on our screen. And here we have a bunch of parameters that we can play around with. So not only does this Cinemachine like allows us to get the camera to follow the player, it also allows us to add damping, which basically means how closely does the camera follow our player. So if we increase like the damping on the X and the Y, you see it doesn't, you know, it takes some time to actually realign to this little dot, which is the target. And if we set it to 0, it will, you know, be very sticky. So depending on what you want, on what type of game you're doing, you will want to like mess around with these parameters. But right now, this is fine for what we want. You can see there's also dead zones. So if we increase our dead zone, you see here, we have this little box where if we move our character around, the camera won't actually do anything until we hit this edge. So that's what dead zone is. So again, a lot of parameters that we can play around with. For now, I'm just gonna keep it at the defaults, and that'll be fine for our purposes. Okay, so well, very quickly, you know, we're not like 10 minutes in when we already have the camera set up. We're going to move on to animations, and I'm going to go to my slides right now. You can see here I've described a little bit how to set up Cinemachine, but we're actually going to talk about animations. So the way animations work in games is let's say you have a character and you want, when you're standing still and not moving, you want him to play an idle animation. And then when you move, you want the animation to switch to play a different animation. And if you fall, you want to play a different animation. So what we use for this in video games is state machines. So what is a state machine? It's basically it consists of a finite number of states. So states in our case are the different animations. So a state machines are these states and the transitions between these states. So as you can see here in this graph, for example, we have our idle, and these arrows are the transitions between this idle state and this walk state. And we'll be able to define this in Unity. So if I go to the next slide here, see this is inside of Unity. So let's go and do that. First of all, we want to create an animation. So we're gonna go to our sprites, heroes, or knights, and as you can see here, we have different folders for different animations. We're gonna grab our idle. And to create an animation in Unity, it's very simple. We're just going to select these sprites. As you can see here, now I have them selected. You select them in the order that you basically want the frames to play. And we're going to hit right-click, create, and go to animation. And let's name it something like anim underscore knights underscore idle. So now we've created this animation. How do we link it to the knights? Well, first of all, we're gonna want to add an animator component. So this animator component will take a animator controller, which will allow us, this animator controller is what is going to allow us to define our different states and transitions. So let's, in this folder, let's create, let's right-click create, then go to animator controller, and let's call it knight underscore animator. If we double click on this, it's going to open a new window for us, which is the animator window. So this is where we define our states and our transitions. And first of all, let's go back to the scene, select our character, and make sure we assign this animator to this controller parameter here. Okay. So now go back to our animator, and very simple. We want to add this idle animation to this animator. We're just going to click on our animation and drag it. And as you can see, it added this anim underscore knight underscore idle state, which is, which if you look here, it's referencing our animation. And this state, this is the entry state. So when you hit start, when this animator component starts playing, it will go from this entry state directly to our idle state. And it's orange right now because this is the default start state. So now, if I go here and I hit play, we should see our idle animation playing. Interesting. It's not playing. Oh, I think I know why. We have a little issue here, is that if we click on our animation, we see there's this loop time parameter, this loop time checkbox. And right now it's disabled. And basically this just means that if it's on, then our animation will loop indefinitely. Now, if we hit play, it should start playing. Why is it not playing? That's strange. Okay. Okay, minor issue here. This is fine. Let's see. I wonder if maybe our animation is just... So let's open up our animation window. So if you go to Window and go to Animation, we'll open up this little animation window. Let's dock it here next to the console. And select that player. Actually, it seems that this animation was not actually created properly. That's interesting. I'm not sure why. That's okay. So let's do this again. I'm going to delete this animation. Actually, no, I'm not going to delete it. I'm going to show you how to... Actually, you know what? I am going to delete it. Never mind. We're going to create this animation again. I think the problem was that I needed to select these sprites like so, instead of selecting the sort of PNG. You want to select the actual sprite here. And now if I hit create animation, hopefully it should work. Anim underscore night underscore idle. Let's see here. Yes. Now you can see here in our animation window, we have this night idle animation, and as you can see here, it's very small, but we have the 4 different sprites that this animation consists of, basically. So let's go back to our animator window, and if we select the state here, we'll just take this animation and place it in the motion parameter, and make sure loop time is set to true, and hit play. Oh, he is tiny. That's because we need to do something that we learned to do last time, which is always remember to set the pixels per unit to 16, at least for this project. Exactly. Oh, you're right. This is the run folder. Whoops, my bad. Okay, that's okay. We're just going to do this again with our idle. Mistakes happen. Anim underscore night underscore idle. Okay. Now just quickly, I'm going to remove this. And actually, I'm going to go here and I'm going to create a folder just for my animations. And I'm going to drag this animation here and this animator controller here. Okay. So now we should actually have our idle animation. Let's just, again, set these PNGs to pixel per unit of 16. There you go. And again, go back to our animator. So as you can see here, even though I deleted the animation, the state machine was not affected. Only the state itself lost the reference. So we're just gonna again replace it, and now hopefully all should be well. Yep, as you can see. Oh, I think I forgot to hit loop time once again. Let's just do that. And I also noticed that we need to set the filter mode for these sprites to point no filter. Go back to our animation, hit loop time. Okay, 5 times the charm. Okay, there you go. The animation is playing correctly. And it's looping and moving around. And he's just bouncing up and down infinitely, and he will keep doing so. And actually, let me just hit play again. If we look at here at our animator, and if we select our player character, you can see that this blue line basically, it's actually repeating, but it's reading so quickly that we can't actually see it. But this blue line means that this animation is playing. Anyway, okay, so now we have this idle animation. Let's add the run animation. Let's, first of all, let's select these, hit filter mode, no point, no filter. Okay, select them again. Oops. And hit create animation. And let's call this anim underscore night underscore run. Okay, let's drag this to our animation folder. Okay, back to our animator window. We're going to take this, let's make it small so I can read them. Let's take this run animation and place it here. So now you can see we have two states. This orange state, now that you can see, now that we have multiples, only this one is orange, and that's because this is the default entry state. Now let's think about what we want to happen here. If I'm not moving at all, I want to play the idle animation. So I want it to be in this idle state. However, if we move, if our speed, the speed of the character is greater than 0, I want it to transition to this run state. And if I stop moving, I want it to go back to this idle state. So let's create these transitions. From our idle, we hit right click, make transition, and you see it creates this error for us, and we're just gonna hit the run. And now you can see here in our transitions, we have idle to run. And same thing, from our run, we're gonna hit make transition and create a transition from our run to our idle. Okay, so now we have these transitions, but they won't actually ever be called. It will only ever be in our idle. That's because we need to actually write some codes for our to interact with our animator controller components to tell this animator to do the correct transitions. So first of all, if we click on our arrows here, we see we have a couple of things. We have some settings here that define how this animation transitions to the other one. So the exit time from this animation to this one right here is set to 0.25. So actually we want to hit to uncheck has exit time because we want the animation to transition immediately. And let's set the transition duration to 0 for the same exact reason. And we see we have this conditions list here, and we can add as many conditions as we want. And see, it tells us parameters does not exist. So we want to give this condition a certain parameter that will determine the condition of why it will transition. So for us, in this case, we want to check the speed of the player. So we're going to create a float parameter. Let's call it speed. And now that we've created that, if we click on our transition and go to our conditions, we see we have a little drop down here. And we selected speed, and you can see it says speed greater, and we can select greater or less. And here we have 0. So basically here you can define the conditions for this transition to be called. So in our case, we want it to actually check if it's greater than 0.001, then go to our run state. And in our run state, if you detect that the speed is now less than 0.01, we want it to transition back to our idle state. Okay. So now, if we hit play, nothing actually will change. Nothing will happen. Our idle is still the only animation that's playing because it's not transitioning to our run state. I want to do that through codes. So let's go to Visual Studio. I hope everybody can see it. And okay. So in order to define these transitions, we want to communicate with our animator controller, with our animator component, excuse me. So let's first of all create a field for it. Let's animator. There we go. I'm just going to call it animator components. Let's in our start. Oh, well, that it already knows what I want. Animator component equals get component animator. So we're just getting the animator component that's attached to our player game object. Now this animator components, let's say here in our movement inputs, let's access its functions, and we want to call the set float function. So here you see it says sends float values to the animator to affect transitions. So we're gonna the first parameter is going to be the name of the parameter that we created in our animator window, and the speed is just going to be our current movement speed. Yeah, so it's going to be so we're going to take our movement inputs and take the magnitudes, which is just the length of the vector. So, oops. Which is just the length of the movement input vector. So if we're not hitting any of the movement inputs, it's going to be 0. And if we are, then it's going to be greater than 0. And a slight, very slight optimization that we can do to this is actually called square magnitudes, which is a little faster, but it basically does the same exact thing. So now if we go back, we'll go back here. First of all, let me hit play. And I'm going to take the animator and dock it next to our game view. So you see here our speed parameter. I can actually access it from here. So if I set it to 1 or it's actually resetting to 0, which is why it's not working. Well, it's okay. It's okay. It should be working now when I move it. So if we move, you can see the speed is being set to 1 as I'm moving, and as you can see, obviously right now he's just skating around. That's because, again, we forgot to hit loop time on our animation. So now it should be fine. There you go. Now he is actually moving his legs appropriately. And yeah, you can see here our speed is being updated. So now it's, and if I stop moving, it will transition back to our idle. And if I start moving, it will immediately transition back to our run. And see now, if I stop moving, it will actually take a second to go back to idle. And you can see here, it doesn't go immediately, whereas the inverse is not true. That's because this thing that we did here, which is uncheck has exit time, we did not do here. So we're going to do that for this transition as well. And now it looks much, much better. He's moving, stops, goes to idle, and there you go. So that's basically how you create a very simple animation. Okay. Okay, next, we're actually going to create, let's give this guy a weapon that he can swing. Because right now he's just walking around. He's supposed to be a knight, but he has no weapon. What a bad knight. Let's give him a weapon. So we're going to go here to our weapons folder, and you can see we have many different sprites that we can choose from. I'm just going to go with this sword right here. As with anything, I'm going to set the pixels per unit to 16, filter mode to point no filter, hit apply, and I'm just gonna drag this and place it under my player character. Going to you can see it's not placed exactly where I want it to be, so I'm going to hit reset on the transform, and now it's snapped back to 0, which it's parented to our player characters now. Whenever I move the player, the sword will always be in this position. So let's actually move it appropriately, something like this, a very big sword. And so what kind of animation do we want here? We actually want this knight to like swing his swords. But as you can see, if I hit E to go to the rotation tool, and I rotate it, it's rotating from the center of the sprites. And I kind of want it to like, rotate from the handle. So to do that, I'm going to click on my player character, right click, and hit create empty. And I'm going to create just an empty game object and call it pivot. And I'm actually going to parent this anime sword to our pivot. And now if we position our pivot to somewhere like over here and take our sword and like position it a little further up, let's zero it. Oops. Actually, this is fine. Now, oops. See here I have global in this little dropdown. This actually lets you see the transform tool can have different settings. So if I select local here, I want it to be local, and I want the pivot to be here, and the weapon to be here. Let's see. Weird. What is happening here? This is the pivot is moving with our weapon for some reason. How come? So weapon should move independently. It's a bit weird. I'm going to delete this real quickly. Okay, here's our pivot. We need to place it here. And let's drag this here. I think this is what's actually. There you go. I had to select pivot instead of center, because this will always show the center of the object, while pivot will actually. So this is what we want. There you go. Now you can see our weapon is placed slightly above our pivot, and if we select the pivot and hit E for rotation, or you can just select the rotation tool. There you go. If we swing, we change the rotation on the Z. You can do it like so also. You can see we can actually create a nice little swing here. So let's animate this. Let's create this animation. How do we do this? Let's go to our animation window, make sure we have the player character selected. And we're going to, in this little drop-down, click create new clip. It's going to open up a little window here. We're going to go to our animations and create a new animation called anim_knights_attack. Hit save, and it's created a new animation clip for us. So here we can do any number of things. So we want to animate basically our pivots rotating. So to do this, we're gonna hit this red button here, which will place the animation into recording mode. So anything we do now, you see, it will create based on where we set the timeline. It will create a keyframe at that point. So now, if we open this up, you can actually see at 0, it will rotate the pivot to -39, and at 20 it will do it go to -88. So actually we want it to start from 0, and yeah, let's have it do something like this, and then let's have it go back to 0. Okay, if we hit play here, there you go. We have a little swing animation that's happening. Awesome, awesome. So let's go back to our animator, and let's add this animation. Oh, you can see here, it automatically created the state when we created the clip. It automatically added the state to our animator. So this is not actually. So if we think a little bit about what we want to happen, we want the knight to be able to attack whether he's in the idle state or if he's in the run state. So regardless of the states that we're currently in, we want to be able to play this attack animation. In order to do this, we can create separate animator layers. So if we go to layers over here and hit the plus, we can create an attack layer. And this will basically be kind of like its own separate state machine that runs independently of this one. So let's, first of all, let's delete this state from here, and let's add it to this attack layer. If you go to animations, drag it in, there you go. Let's, very important, right now, it won't actually play. Let me show you. Oh my God. It seems my Unity has crashed. Oh, no, false alarm. It's fine. Oh, no, it crashed. Okay. It happens. It happens. I'm not sure what I did to make it happen. I hope I saved. I'm not sure when's the last time I hit Control S, but it should be fine. The animations and everything should still be there. Yes, this is what Ayad is saying is very true. Always hit Control S. Get used to hitting Control S very, very frequently. So we're just going to wait a second for this to open up. How's it going so far? Since Unity is going to take a second to open, if you guys have any questions, let me know. Okay, so we just added. So first thing we did is we added the Cinemachine package, which is just a package that allows us to add a camera controller, basically. Okay, you know it. And we started adding animations, so you didn't miss much. Okay, I think it opens. Oh my God. Okay. Okay, I'm gonna try to open it again. There's a thing with like Unity Hub. There's something happening with the licenses, so it's an issue for the Unity folks to like get it together, basically. Okay, there you go. There you go. It launched actually pretty quickly. Okay, let's see. We still have everything open. There you go. Okay, so we didn't actually lose a lot of progress. We just need to create the layer again. So let's hit plus, task layer, and I don't see Unity. Oh, okay. I need to actually reshare it. Sorry about that. Let me add it back. There you go. You guys should be able to see it now. Okay. Okay, so yeah, we're back to where we were before. Let's just delete the state, add it back to the attack. There you go. Pray to the Unity gods that it does not crash again. Hit play. There you go. So if we look here, I selected the attack layer here. It's playing the attack animation, but you know, our animation is not actually playing. So why is that? Well, basically, if we hit this little gear, you see you have this weight. And basically this weight, if I drag it, you see the more I'm dragging it, the more this is actually this layer is starting to take effect. And you know, this is very cool if you have like, you know, lots of complex, you know, like 3D animations where you're transitioning between different animations. This is very powerful too, but for us, we kind of want the weight to be always set to 1. So now if I set it to 1, as you can see, it's always playing the attack animation, but it's also playing the attack animation regardless of whether I'm in the run or in idle, which is what we want. However, what we don't want to happen is for it to be constantly playing. So what we're going to do, I went, once I went out of play mode, I had to set it again. We're going to create a state, an empty state, and we're going to say set as layer default states. So now this new empty state is the default state. And basically we want to transition from this empty state to this attack state whenever we detect the attack inputs, which we will create the code for in a second. So first of all, let's create the transitions like so. And so before we created a float parameter to control our speed, now we're going to create a trigger. And let's call this trigger attack. Trigger parameter is just, it's kind of like a Boolean that gets, when you call it, it just gets set to true for one frame and then automatically back to false. So you're just like triggering it for one frame and then it's like unsetting itself. And this is kind of what we want for our attack. We want, to hit the mouse button, have the attack play, and then, go back to the empty state. So real quickly here, I'm just going to remove has exit time and set transition duration to 0 and do the same here. Okay. So now let's go to our player controller script and add an attack function. So under here, we're going to call void attack, create a new method, and we're going to call animator, actually, we're going to say if inputs dot get mouse button down 0, animator component dot set trigger, and the name of the trigger that we created, which is attack. So what are we doing? We're just checking if input.get mouse button. So if we click, I believe this is left click, 0 is left click, 1 is right click. I might have gotten it wrong. We'll see in a second. So if we detect that the mouse button is down, we're going to call this trigger on our animator. So let's actually call this function. Let's call attack here in our updates. That way it's, every frame it's checking whether we clicked the mouse button inputs. Go back to Unity and let's hit play. Let's see. Okay, I'm clicking and you can see nothing is happening. Oh, I know why. We actually forgot to, my bad, I forgot to set the conditions here. So let's just set attack, and we'll just have, actually for this transition here, we want it to have an exit time because we want the full animation to play, and then once it's done, to go back to our state. So now that we've set the condition here, if we click attack, there you go. You see it's snapping back. It's not playing our full animation. That's because on this transition, the duration, the exit time is set to 0.5, and we want it to be, so it's playing like a little bit over half our animation and then exiting. We want it to be 1 so that it plays our full animation. Now if I press click here, you can see it's playing the full animation. Okay, there you go. Yeah, and here it actually remembers the changes that I made. No need to do it again. Okay, so now we have some very basic animations. but we actually have nothing to interact with, you know, our night is kind of just lonely. There's nothing else in the scene. So let's create some stuff for him to interact with. First of all, you know, I would like to create a health, to give this knight some health, and to give him to add a functionality for him to take damage. Okay, so first of all, let's give him some health. We go back to our player controller and let's add a public float, or rather a public integer, public int, and call it health. And let's set it by default to 4. And I'm going to create a function that right now is just going to, this is the building block for our damage function. We're going to call it take damage. We're actually going to have it be a public function, public take damage, public void take damage. And here we're just going to say health equal to health -1, which there is actually a shorthand for this. You can also say health -, which is basically the same thing. So let's do that. This will just take our current health and remove 1. Okay. Oops. So we have our take damage function. Right now, you know, it's not doing anything. I'm actually going to add, you know, I'm gonna add a debug.log here that will just say, you know, player damaged, so that I know whenever this function is called. And okay, let's add some spikes, and we're gonna take a break right after we do this. Let's add some spikes. If we go to our tile assets, or sorry, our tile sets folder, and we open up our tile map here, let's scroll down a little bit, and right here we have this little spike sprite. I'm just gonna drag it to the hierarchy, and you see here we have this spike game object that is just a transform and a sprite renderer, and you know, we can move it around. Okay, so also quick tip, if you hit Control, it will actually, when you're moving the transform, it will snap to like, I think it will snap to like the Unity grids. So it's useful for moving it around when you want to set things up, you know. For example here, it would be weird if it was like in the middle. We want it to be aligned with the tile. So let's rename this. Let's rename this to Spike, and we're going to add components. We want, whenever the player moves over this spike object, we want to call the take damage function that we just created on our player. So how do we do this? We're going to add a collider component, a box collider. So box collider 2D. And as you can see, it's created this collider. Let's open it up. And you know, right now, let me just show you really quickly. If I move And right now the player is actually colliding with this object, which is not what we want. You know, the reason we created this collider is to be able to detect whether the player is, you know, going over it. So what we can do is if we hit its trigger, now, you know, we can move over this collider, and basically this is the difference between colliders and triggers is what you just saw. A collider will, you know, physics objects and rigid bodies will collide physically with a collider, while when you set it to be a trigger, you can still detect when an object is overlapping with this box collider, but it won't actually physically stop your rigid bodies. Okay, so now let's create a spike script. So we hit add components, spike, and let's hit new script, create an add. Well, right now, nothing will happen, right? Right now, the player is just going to walk over the spike and nothing will happen. We are going to add the functionality for it to actually damage the player. So to do this, we want to detect when the player is, you know, enters this trigger. To do this, we have the monobehavior class gives us this functionality. Let's write on trigger enter 2D. So the name is kind of self-explanatory. When an object that has a collider attached to it enters this trigger, trigger object that we have, this trigger components that is on our spike, it will call this function. So real quickly, we're just going to say debug.log trigger, or I'm just going to say on trigger enter 2D. Okay. And let's see what that does. Hit play. Okay, as you can see, there's nothing in our console. But when we move over it, there we go. When I enter, and only when I enter, this on trigger enter 2D function gets called. And there's actually a number of other functions like this. If you just write on trigger, you can see we have on trigger exit 2D, which will be called when an object exits the trigger. And you also have on trigger stay, which is called every frame that this object is inside the trigger. But for our purposes, we just want to, you know, have the player take damage when they enter this object. So how do we do this? If you see here, this function takes a collider 2D parameter, and this collider 2D is the collider that's entered the trigger. So we want to check, okay, let's say collision, sorry, if collision dot compare tag player. Okay, so what this is doing is, let's remove this debug log. I'm actually going to comment it out. What this is doing is, when any object with a collider enters this trigger, it's going to check the tag, and it's going to check, and if the tag is equal to player, it's going to, you know, execute whatever is in the if statement. So if we select our player character, and go under tag, we have a number of tags that we can set. See here, we have our player tag that is, it's a default tag that's already, by default created when you create a project. And you can hit add tag and add as many tags as you want. And if you go back here, they will appear in the dropdown. But for now, we just want it to be player. Okay. So let's add another debug log. So debug log player collision. Okay. So now, again, if we go here, there you go. Player collision is being called. And right now we don't have any other objects besides our player, but let's say, for example, you had an enemy or like a box or something, and they moved over this spike. You might not want to call not want to call this function, which is why we are adding this check here. Okay, so let's call our take damage function. We're going to go collision dot get components player controller. So now we're taking our collision and we're taking the game object connected to the collision, and we're getting the components, the player controller components, and we're gonna call take damage. So this is why we created this method with the public accessor, because we want to be able to call it from this method, from this class. So now it should call this take damage function. Yes, exactly. Okay, let's hit play. And there you go, player damaged. So now if we look here, our health is going down every time we're going over the spike. Okay, let's take a quick 5-10 minute break. I'll be here if anybody needs, if anybody has any questions, and we'll come back in like 10 minutes. Okay, I think that break was long enough. Okay. So now we've added our animations, we've added a simple damage function, but as you can see, it's not, we have no way of actually visualizing what is happening. So let's change that. Let's add a simple HUD. Welcome back. Okay. So let's add some simple UI. How do we do this? We're going to create, hit right click in our hierarchy and go to UI, and let's create a canvas. So a canvas is basically where all user interface, all of your user interface objects are drawn. For example, let's create a panel, and you can see here in our game view, this panel is spanning the entire screen. I can, shape it and put it up here. There we go. And yeah, as you can see now, as I change the size of the game view, this panel actually is growing. So if we go here to our canvas, we have some different render modes: overlay, camera, and word space. Overlay is the one we want, but to really go over the other ones, camera will basically mean that it's attached to a specific camera, and here you can see you can select which camera is rendering this canvas. And world space means that this canvas is actually part of the world. You can see it disappeared here. This is useful for when you want to add UI elements to the actual scene. That are not like attached to the camera itself. But let's keep it at overlay. And if we go here to canvas scaler, we have a UI scale mode, and right now it's set to constant pixel size. We want it to actually scale with the screen size. So this will allow our, all the UI elements in this canvas to basically scale depending on our on the size of our screen. So now, doing that, our little panel here is now scaling correctly depending on the aspect ratio, and you can see this little job down here. By default, you start with free aspect, which just means you can change the game view however you want, but you typically want to have it set at 16.9. This will determine the aspect ratio of this the game view. I recommend setting it at 16.9 just to make sure you're seeing what your players will be seeing, basically. Okay, so we want to display the current health of our player, and we want to have that health change whenever we take damage. So let's see here in our sprites, we have a UI folder with some hearts. So I'm going to select all these sprites and pixels per units and filter modes, as always. Okay. So I'm going to take this heart full sprite and I'm going to place it inside of our panel. And let's see, put it right at the origin. I'm going to actually place it here. Actually, let's do it a different way. So this panel is where I want my hearts to basically reside. So what I'm going to do first is actually create an image. So this is basically the equivalent of like a sprite, but for UI. This is what allows you to render sprites on a canvas. And if you want to display this heart, we're just going to take our heart sprite and put it inside the source image. There you go. Now we have our little heart here. And we want to have multiples lined up next to each other, but instead of doing it like this, where I just copy and place, try to place them all at an equal distance, what we're going to do is go to our panel and we're going to click add component, and we're going to add a horizontal layout group. So this will control the layout of the child objects under the panel. So if you look here, we have a couple of options. We have the spacing, so we can control the spacing between our images. So let's make it a bit smaller. Actually, first of all, we're going to remove force child expand on the width and the height. And we're going to set the alignment to be middle left. So now it's aligned to the middle of our panel. And we're going to just make the spacing a bit smaller. There you go. I'm happy with that. Let's make this panel a bit smaller. There we go. And I'm actually going to change the color here, and just maybe I'll keep it, but I'll make it a bit dark. There we go. Okay. So now we have a little HUD. But right now it's not attached to anything. This is just basically a display and nothing else. So let's change that. Let's make it so that whenever we walk over, we take damage, we remove a heart. So on this canvas, we're going to hit add component, and we're going to create a new component called game UI. Let's create it and go to Visual Studio. Double click it. There we go. So okay. So what do you want to do? Basically, every time we take damage, we kind of want to go, come here and delete a heart, right? So how do we do that from scripts? So I'm gonna rename some of my objects here. I'm gonna call these hearts heart image, just so that it's a bit more organized. I'm gonna call this health parents. And the canvas, I'm gonna rename it to the game UI canvas. Okay, just so everything's a bit cleaner. Okay, so how do we delete these hearts from code? Well, first we're gonna want to access this object here, this health parents. So let's do that. Let's do public game object health parents. So now go back to Unity. So go on our canvas. In our game UI script, we have the self parent, and we're just gonna drag this panel and place it here. So now this game object is assigned to this parameter, and we can access it from code. So let's get rid of these functions. We're not gonna use them. Okay, let's create a method. Let's call it public void damage. And it's gonna take an integer parameter called damage amount. Okay. So the function, the logic here is going to be that for every damage amount, so let's say in the case of the spike, it's going to be 1. But let's say we have an object that's damages us for 2 points of health. So for every damage amount, for whatever this number is, we're going to remove a health sprite. So we're gonna say 4, and I'm just gonna hit tab twice, and it's gonna automatically do this for me. So let's walk through this. This is for integer I equals 0, while I is smaller than this value, which we're going to set it to be damage amounts, I plus plus. So I increments by 1. So this is a for loop. And what it's doing is that, I starts at 0, while this I integer is smaller than this damage amount value, it's going to increment by 1 and call this code again. So I'm going to do a debug.log here and say in game UI damage. Maybe not the best thing to write, but it's okay. And okay, how do we actually remove that object? We're going to call a very handy function called destroy. So this destroy is basically the equivalent of deleting an object. So we want, okay, let's just, right now it's throwing an error because it has nothing inside, but that's fine. We want to destroy the child of this health parents, which are these hearts. But specifically, I want to destroy this child right here, right? Because this is this one right here. So what we're going to do is call health parents dot transform dot get child. So we're accessing the children of this transform. And here you can see it takes an index. And this index is basically, so these children, this get child will access these children depending on their index. So this is index 0, this one is index 1, 2, and 3. Remember, in programming, we always start from 0. So to access this child, we're going to call health parents dot transform dot child count. So the number of children we have -1, and let's say dot game object. So here we're getting the child at the index of child count -1. So whatever the current number of children are -1, and we're accessing the game object, and we're saying basically destroy this game object. I hope that makes sense. Let's see if it works. Actually, right now nothing will happen because we're not actually calling this function anywhere. So let's actually go ahead and do that. We'll go back to our player controller, and we want to access that function. So let's add a reference here, game UI, just call it game UI. And we want to somehow, from our player, find this game UI script that we've created here, this game UI components. To do that, we have a very useful function called find object of type. So let's hit game UI equals, and we're going to set it as find object of type game UI. So this function here is basically searching through all our game objects in our scene and looking for the first component of type game UI. This function is actually very, very expensive, right? Because it's looking through all the components in your scene. So it's very, very unwise to call this function a lot. You should, it's fine to call it at the start or in a wake, but you should, as a rule of thumb, you should never call this during your updates method because it's a very expensive function. And when you can, you should just avoid calling it. But for now, this is how we're doing it. Okay, so now we should be getting a reference to our game UI component. And here in our take damage function, we're going to call game UI dot damage, and we're going to pass 1 here. Okay, let's hit play and see what we've done. Okay, I'm gonna walk over to the spike, and no, as you can see, it's deleting the hearts. Walk over it again. Let's walk over it again, and now it should actually throw an error. Yes, transform child out of bound. This is because right now, we're trying to delete hearts, but they're not there anymore. So it's telling us that, hey, if we double click on this error, it will show us where the error is being called, and it's right here in our destroy. And that's because when we're doing get child health, health parent or transformed or child count -1, it's actually because this is 0 when the health reaches 0, it's actually saying get child -1, which doesn't exist. So obviously the way we would like to avoid this is to actually do something when you hit 0 HP. In our case, we're just going to reload the current scene. So let's do that. So actually, I'm going to create a private function called check death, and I'm going to say if health smaller or equal to 0, let's write a debug log here. It says player dead face. Oops. And we're going to reload the scene. So to do that, we're going to access the scene management. We're going to actually go up here and get the scene management classes to be able to use them. So we're going to say using Unity engine dot scene management. So this scene management namespace gives us access to everything we need to load scenes, unload scenes, and whatnot. For our case, now if we write scene, okay, you see here we have a scene manager dot, we're gonna say load scene, and you see here it takes an integer, which is the scene build index. So we want to reload our current scene. So what we can do is go scene manager dot get active scene. Oh, and we also need to say it also needs to take a load scene mode. So let's write load scene mode, and you have 2 basic ways of loading a scene, which is single and additive. Single basically means that dot single index here. So I'm going to walk through this. So load scene modes, single means that it will load over the scene that you have, right? The currently loaded scene. So this is the simplest way to load a scene, is basically just removing all the current scenes and loading a different one. And additive means you're loading on top of that scene, so you can add multiple scenes onto each other. For now, this is what we need. And here, scene manager dot get active scene dot build index. So what is this build index here, right? We can kind of understand what this is doing, right? It's getting the currently active scene, which is our sample scene here, and it's getting its build index. But what is this build index? So let's jump over to Unity and let's go to File, Build Settings. So here we have our build settings. This is basically, we'll go through this again at the end, but this is how, these are the settings where you kind of, you generate the executable file for your project, which we call a build. And here you have scenes and build. So this is, right now we only have one, but you can have multiple scenes here, and all the scenes in this list will be the scenes that are included in your build. So as we see here, this 0 is the index of this scene. This is the build index we're referencing there, right? You'll see, we'll be adding a main menu scene, and we'll have to add it here later on. But for now, this should be enough. We'll take damage, and remove 1 from our health variable, call the game UI, and then we're going to check death, check if health is less or equal to 0, and if it is, we'll reload the scene. Let's do this. Let's test it out. I play. There we go. Boom. So when I hit 0, everything resets. My entire scene resets to what it was at the beginning. There we go. And we can do this as many times, and it will constantly reset. Okay. So that's a very basic way to handle death. In a more advanced, project, you might want to do more stuff. You can add some, you can trigger like a very specific death animation, play some visual effects, a sound effect, maybe play a transition so that it's not so, see when we died, it's like snapped back. You can add some like scene transition to make it smoother. But for now, this is enough for us. Okay. So let's see. What's next? Okay. So let's add another scene. Let's add a main menu. How do we do this? We're going to create a completely new scene. So let's go to our scene folder and let's hit create and scene. Call it main menu. And let's double click. As you can see, we've loaded in a completely new scene. So the menu is going to be very simple. It's just going to be, again, a canvas. So let's create that. Canvas. And we're going to create some simple, let's create a text, a title, and 2 buttons, one to start the game and one to exit. So as you can see here, when I clicked on to create the text, which was a text mesh pro text. This is a text mesh pro is a package, a very, very useful package that will basically the default Unity texts are very, very, very bad. They don't really render correctly. So instead of fixing it, they decided to just and somebody was nice enough to create a package for it, and Unity is just using this package. So we're just gonna hit import here to import Text Mesh Pro to be able to use it. And there you go, that was very quick. And now, as you can see, we have a text displayed on screen. So click on it. Okay. So let's put, so you can see here, this is our Text Mesh Pro text component, and it has a bunch of different options that you can mess around with, like font size, you know, bold, you can have italic, underlined. There's a lot of things you can mess around with. Let's rename this to just top down 2D, because I am bad at naming things. And let's hit auto size. I'm going to scale it down, put it up here. So that's a very, very simple title for our game. I'm gonna just change the color of the camera to be just dark like this. Okay. So now we have a title. Let's create some buttons. I'm gonna go to UI, and as you can see here, you have this button, Text Mesh Pro, which is the one we want. Let's create it. It's going to create this very, very big button. Let's make it just a little nicer. Hit auto size on the text, and let's make this button smaller. Oops. And let's center it. I'm gonna make this text a bit smaller. I'll also make sure to always put in the scale mode to always have it set to scale with screen size if you want it to look good no matter what the size of the screen is. I'm gonna make this text a bit bigger now. Okay, now it's very, very small actually. Let's make it a bit bigger. Okay. Let's say something like 20. Oops. Okay, that's fine. Let's call this button start. Okay, I'm gonna also name the game object. Oops. Start button. And I'm gonna duplicate it and just drag it down. I'm gonna call this one exit button. And I'm gonna rename the text here to exit. Okay, so now we have some buttons and the title. If we hit play, what do you think is gonna happen? Nothing. We can see it's a little hard to see, but you know, we can actually click on these buttons. They just don't do anything. You know, they change their colors and whatnot, but they're not actually doing anything. So we want to create that functionality that we want. So let's look at this button first of all. You see this button game object is made up of a couple of things, which is a rect transform, which is similar to a transform, except it also has a width and a height, and that's basically the equivalent of a transform for, you know, UI elements. You have an image, which is again just a sprite, a color. You know, it's rendering this background, and you have this button. So this is where the button functionality is actually being defined. You have these different colors. These are like, you can change these colors around to change the color, like when you press the button, what color the button changes to and whatnot. And you can mess around with these, but what we want to focus on is this on-click thing over here. So whenever you see this is basically a Unity event. And this is an on-click event. So whenever you click on this button, it's going to call this on-click event. right now, it's not doing anything. If you hit plus here, you can see it's added a little segment here. Basically, you can add an object here. Let's say, for example, let's just put the canvas here, and you can access the functions of the different components that are on this canvas. So you see here, this canvas has a canvas scaler, and it has functions on that canvas scaler that you can call. So we're gonna want to create our own custom components to do to implement the functionality of these buttons. So let's do that. Let's create a main menu script. I'm going to get rid of these. Okay. Okay, so this is actually very simple. So what do we want this button to do? Once we want two functions basically. We want a public void on click function, on click start function, and we want a public void on click exit function. So one function for each button. And the on click exit, it's very, very simple. There's a Unity function called application.quit. This will just quit the application. I'm gonna actually add a debug log here, debug.log, and you're gonna see why in a second. Say exiting game. And for now, I'm just gonna call a debug.log start game here. Okay, and let's go and see what that does. So we've added these functions. I'm just gonna hit play. It's not gonna work, but that's okay. So it's not working. And the reason is because we didn't actually set them here in our onClick event. So now if we drag our canvas, and it's already here, and we hit this dropdown, you see we have a new component here, our main menu. And in our main menu, we can access our functions that we just created. So let's select onClick start. So now whenever we click this button, it will call this function. And for our exit, same thing. We'll just do this, add our canvas, onClick exits. Now, go to the console, and I hit exit. See, it calls exiting game. It doesn't actually do anything because right now we're in the editor, and once we create the build and play it, it will actually exit the application. But right now, it will just throw out this debug log. And if I hit start, same thing, start game. So now let's actually implement our start game function. We're gonna say, so similar to what we did before, we need to add using game engine.scene management because we want to load our first level. So let's say scene manager dot load scene, and we're gonna say load the scene with build index of 1 and load scene mode single. So now we're telling it to load the scene that has a build index of 1. Why is that? Because, and let's go to our build settings. Here, first of all, we're gonna want to add our main menu scene here. And we want our main menu scene to be the first one. But whichever a scene is at build index 0 is going to be the first scene that's loaded. So for us, we want it to be the main menu. And once we did that, the sample scene is now at build index of 1. So I hope that makes sense. If we hit play and we hit start, oh, whoops. You can see we need to actually add it again. Let's hook it up again. Main menu, click exit, let's play. And if we hit start, there you go. Now we can load the scene from the main menu. Boom, boom, boom. And yep, everything's still working fine. What's the difference between load scene and load scene async? So async stands for asynchronous. Asynchronous basically means so loading async means that you're loading a scene usually when you're okay, sorry. When you're loading a scene using just load scene, it will sort of like stop everything that's happening, load that scene, and move on. Yeah, loading async, what it does is that it will keep your code running, and it's in the background will load the scene. So if you have like a very, very large scene that you're loading, you want to load like you want to use maybe loading async to load it in the background while other stuff is happening. Okay. So now we have our very simple main menu with a start and an exit. Okay. Let's go back to our sample scene. Save it. Okay. So you might have noticed that we added an attack. Actually, first of all, before we get to that, let's go back to our spike here. Let's say I want to add like multiples of the spike object. We could just hit Control D and duplicate it, place it around. But let's say now, I'm 5 months into making this game, and suddenly I want to change the spike. I don't like the sprite anymore, so I want to change it. If we did it in this very, very naive way, then we would have to go through each individual, game object and go and change the sprite, put it to like this, for example, and we'd have to do this for every single game object, which is, it's very, very inefficient and, a very big waste of time. So for objects like this that you want to reuse in your project many, many times, you want to use what's called a prefab. So prefab stands for prefabricated. It means that it means basically that you have an object, a game object that is loaded in with its components and that you can basically use as an asset. You can reuse as an asset. And creating prefab is actually very simple. You can just select the game objects from your hierarchy and drag it to your project folder, and it will create automatically a prefab asset. So now you see the spike is blue. This means that it's a prefab instance. So now let's say you do the same exact thing. Again, you going around placing these spikes everywhere. And let's say now that you want to change the way this looks, I want it to be, red. right? What you can do, instead of going around and changing it everywhere, is now, you see here, we have some new options. You have our override. So these are the differences in this prefab that exist on this prefab instance, but not on the other ones. And we can actually tell it to apply these changes. So if I hit apply all my spikes will turn reds. Okay, let's control Z. Another way you can do this is if you hit this arrow, or alternatively, if you double click on this prefab here, it will take you to this prefab edits view. And in here, you can make changes. Let's look at our game view here. You can make changes to this prefab, and it will automatically affect all instances of this prefab in the scene. So this is very, very useful when you want to, when you have objects that are reused many times in your projects. And it's a very, very important concept in Unity. And there's a lot of things you can do with prefabs. You can have nested prefabs, like prefabs that are children of other prefabs. And you can create prefabs at runtime. There's many things you can do with prefabs that are useful. And I recommend, going through the Unity docs. No, player prefs is a completely separate thing. Player prefs is basically, it's player preferences. It's like, it's a very, very simple way to save persistent data in Unity. Yeah, it's basically a container of data, 100%. It's typically you use player prefs to save like your settings or whatever you have. Okay. So now that we've gone through what prefabs are, let's add a very simple enemy. Okay, and if you guys stick around to the next session that Martasim will be given, he'll actually be teaching you how to, it will be a session all about enemy AI and how to create, semi-complex enemies with different behaviors. But for now, we're just going to create the base of that. So let's do that. Let's go to our sprites. Let's go to our demons, shorts, and we have this little guy, this short, and I wanna add him to our scene. And I'm actually gonna show you a bit of a shortcut to creating like animations very, very quickly. So I'm selecting these, doing typical things, and support unit to 16, with no filter, and apply. And I'm just going to, let's open these up, and let's select these 4 sprites, and I'm just gonna drag this to our hierarchy, and it's going to create this animation automatically. I'm gonna go to our animations folder and call it anim underscore shorts underscore idle. And as you can see, it's has created for me a game object with a sprite renderer and an animator, just by dragging these sprites into our hierarchy. So that's a bit of a little shortcut. So I'm gonna call this guy shorts anim. And if we double click on his controller, you can see that we have this idle animation that will be played automatically, and it's looping. So actually, let's create a folder here very quickly just to stay organized. Night animations. And let's put all our nice animations in this folder. Very important to stay organized, because as a project gets bigger and bigger, you will hate yourself if you didn't do these things from the very beginning. So you don't get lost. So we have this short enemy, and we know that this enemy, we're going to probably use it a lot in our game. So we're going to go ahead and from the very beginning make it a prefab. And let's actually create another folder and call it prefabs. And drag our prefabs into it. And you know what, since we're here, create another folder called scripts. Let's just drag all our scripts into this folder. There you go. Bit of organization. So okay, now we have this short enemy. If we hit play, so I'm kind of blinking in and out of existence right now for some reason. Wonder what happens. I think the animation might be a little messed up on him. So let's check that. Let's open our animation window. Do a little debugging. I think I know what's happened here. This one sprite might not have selected it correctly. Let's short idle. Let's make sure they're all set to. Interesting. This is a bit strange. Why is this nuts? Yeah, I think you are correct. I think it might be actually the sorting layer. So yeah, actually good point. Let's set the order in layer to 1. Oh yeah, there you go. So thank you. I think it's Ayed. Yes, thank you for that. We always make sure to have to manage your layers correctly. We want this one to be the enemies and actually the spikes as well, since we're here to be on the or to be rendered over our grounds. Let's actually have them be at 2. Okay. So now we have our little short enemy. He's playing his little idle animation. It's a very nice animation. Let's create a simple. Let's create our script. Call it enemy controller. So it's going to be a very, very simple enemy. We're just going to have him take damage. And when the player runs into him, we're going to have him damage the player. So very simple. So let's give him a health, say 5 or 4. Oops, public int health. Okay. Okay. So we want to detect when our player runs into him, and we also want to detect when our weapon hits him. Where's my weapon? Why is it not showing up here now? Oh, I think there you go. So to do this, first of all, we're going to add a collider, actually a trigger to our enemy. So We're having box collider, and let's hit this trigger. If you can see here, this when we added this, it looks a bit different than we've done it before. It has this little plus sign. So basically, this means that these are new changes to the prefab. And unless you go and you hit apply all, they will not be applied to the actual prefab. So make sure to pay attention to that when you're working with prefabs. Okay, so now we have our trigger collider. Let's go back to the script. And we're going to say on trigger enter 2D. Let's check if the player collides with our enemy. We're going to have him take damage. So very similar to our sprite script, we're going to say collision dot compare tag player. And we're going to say collision dot get components player controller dot take damage. Okay. Now we also want to detect, when the weapon enters this trigger, and to have the enemy take damage. So first of all, let's create that functionality. Let's create void take damage, and we'll say health minus minus if health smaller or equal to 0. Then we're gonna want to deactivate this object. So we're just gonna say game object dot set active false. So this set active is the equivalent of you see those of doing this, of just deactivating the object like so. So how are we going to detect our weapon? So here's how I'm gonna do it. There's multiple ways you can do it. But this is how we're gonna do it. We're going to add a box collider to our weapon. Again, make it a trigger. Let's just make it a bit smaller so it fits the blade. Okay, and I'm actually gonna add a weapon script here. So this weapon script is going to be very, very simple, actually. It's just going to be a single public int damage amount. And by default, it's going to be 1. So we're just going to use the script to, first of all, identify that this game object is in fact a weapon, and to have the ability to control the amount of damage that this weapon does. So let's say later on in the game you get an ability or you get like a power-up that has you do 5 damage instead of 1, instead of having the amount of damage be hard-coded, which it is now. Right here we're just doing minus minus. We're going to actually check the damage amount here and remove it from our health. So let's change this. Let's first of all add a parameter here that's int damage amount. And we're going to say health equals to health minus damage amount, or a nice shorthand that we can use is health minus equals damage amount. So again, these two, they do exactly the same thing. You're taking the current health minus the damage amount and setting the health value to that. So we're going to do this, and in our on enter trigger 2D, we're going to check whether a weapon enters the trigger. So we're going to say if collision dot get components weapon, sorry, weapon is not equal to null. So I'm doing this just to show you that there's different ways that we can actually check. Instead of comparing for a tag, which we could have done, we could have added a tag to our weapon and compared the tag like we do here for the player. But this is just to show you that you can do it differently. Here, what we're doing is we're basically calling get component. We're checking if this collision object has a component of weapon, and if it does, then it will this will actually return that component. If it doesn't, then it will return null. So we're checking, if it's not equal to null, that means that whatever entered it, this collision that entered is in fact a weapon. And we're going to call take damage, not health, collision dot get components, again, weapon dot damage amount. So we're accessing the damage amount value of this weapon. Okay, so let's see what happens now. We're going to end up making some changes, and you're going to see why. So now, whoops, as you can see, we kind of have another issue with the layers here. If I come here and I attack, 1, 2, 3, whoop, there you go. We just killed our enemy. Let's actually just do a bit of layer. Let's put the knight on layer 3, and let's put, I think that should be actually fine. Yeah, actually, I'm going to add a debug.log here called, let's just say, ouch. This will be called whenever our enemy takes damage. And let's see what's happening here. If I hit play, see there's like a minor bug that's happening here. I can come here, I can attack, and yeah, he takes damage, but see if I just run into him with my sword, he also takes damage. So this isn't what we want. We want, we want it to only be, we want the enemy to only take damage when we are swinging our sword, when we are playing our animation. So let's do that. So I'm gonna set this to 2. Select the renders in front of our spikes, and here's what we're going to do. We're going to go to our animation, select our player character, and let's go to our attack animation. And well, by default, I want this collider on our weapon to be inactive, and I want it to only be active during the during this swing, during this part specifically. So I'm going to hit record, enable our collider, and once it gets to this point, disable it again. And hit record, and now, as you can see, it should be working now. Let's try it out. So now, if we just have our sword over our enemy, it actually doesn't do anything. But if we swing, there you go, it's taking damage. Now it's a very, very, very difficult to actually know what's happening because, there's currently no feedback. Ideally there'd be an animation that plays when you hit the enemy, maybe some screen shakes, something to indicate to the player that, something is happening. I'm not sure that we'll have enough time to get into game feel and feedback, but maybe feel free to do that in your assignments. Okay. So now I'm going to show you, we have a very, very simple game with a character, animations, and it's a very simple enemy, our damage system. So not bad for what amounts to, like 4 hours of work. We have a little game that can actually be really, really nice if you keep building on it. So let me show you. So let's say you want to share this game with people. You want to send them. You're not gonna just send them the Unity project. You want to send them something that's they can double click and run play. So this is where builds come in. If we go to our build settings, as we went through, we have these two scenes. We can hit builds and run. Actually, let me show you here. You can actually choose what platform. What's nice about Unity is that you can export to many different platforms like Windows, Mac, and Linux, or Android, iOS. You have a lot of options. Now let's stick with the basics and just create a build for Windows. So we're gonna click builds and run, and it's gonna ask me for a folder. So actually, I'm going to create one very quickly. Oops. Let's just create a new folder, call it top down build. I don't think you can actually see what I'm doing right now, but it's fine. Okay. And now it's going to build our project to this folder. Gonna let it do its thing for a second. It's getting a bit late, so we're going to wrap up very soon, don't worry. I'm just going to show you basically this build and show you how to set up GitHub very quickly, and that will be it. And also like talk about maybe what the assignments will be. Okay. So let me quickly share this new screen that opened up. So because I hit play and run, it actually automatically ran this executable file. And as you can see here, we have our main menu. We can hit start, and we have our game here, with all the functionality that we have been working on. There you go. And right now, it's actually pretty bad. We don't have a pause menu, so we can't actually exit the game in a normal way. I'm going to have to force close it, which ideally you don't want to do. You want to add a pause menu where you can actually go back to the main menu and whatnot. But since we're running out of time, I'm not gonna go over that. Okay. So very quickly, I'm going to show you how to create a GitHub repository for your project. If the first thing you want to do is download GitHub Desktop, and once you launch it, you'll want to sign up, sign into your GitHub accounts, and you'll be greeted with this screen. You'll want to go to ads, and then click add existing repository, hit choose, and you're going to navigate to your to wherever you have your Unity projects. Hold on. actually create a new repository. Let's name it, GA top down. And again, navigate to it. This is the one. And here in get ignore, you want to select Unity. There he is. This will just, make sure that when you're pushing things to GitHub, it ignores all the useless files that you don't really need to share with other people. Hit create repository. This will create a new repository on github.com. That's basically, the reason we use GitHub is to be able to share things with your teammates, whatever changes you make on your local device, to be able to share them with your teammates and see their changes as well and whatnot. So now we've added this repository. If I come here and let's say I don't want these spikes anymore, and I delete them, I save my project. If I go back to oops, I closed it. My bad. Let me open it again. Hold on, sorry. Yep. Open it again. Let's go back to Unity in a second. Okay, maybe I did this incorrectly. In this folder. Yes, this is what I should have done. So ignore what I did before. This is the correct way to do it. Same thing, create repository. Now it should work. Nothing. It's okay. Okay, there you go. Now this is here in this view. You can see all of our changes here. We're just gonna call, we're gonna commit these changes. We're gonna call it initial commits. And we're basically going to, all right. I forgot that initially it does this on its own, actually. So we don't need to do that. Very quickly, commits are just committing something is pushing something, saving something locally to your branch. Let's publish it, make it live. Sorry, this is taking a bit of time, but we're basically done. Okay. So yeah, let's add back our spikes here. And if I go to my GitHub desktop, you see we have this changed file, which is our Unity scene. We can say added 5 spikes. This is just naming whatever commits we're doing. Hit commit to main, and now nothing's actually changed in our actual GitHub, in the GitHub that's available to everybody that it's available to. But once we hit push, it's actually pushing our changes to the repository that is online. And that's basically how GitHub works in a very simple way. There'll be links in the slides, which I'll share with everybody. Actually, let me share them right now. Or actually, I'll share them on the Discord so that everybody can have access to them. Okay, that's it. Does anybody have any questions? Can you wrap up what you did in the session so far? Okay, so we added a camera using the Cinemachine package, which allows a camera that follows our player. We added animations that to our player, and we added animation states that control the logic behind how our animations transition from one another. We gave our player health and UI to represent that health, and functionality to take health away, and when we did the same for our little enemy here, and we created some game objects like these spikes and whatnot. So for whoever is doing the assignment, this is basically what you have to do. You know what, everything that we covered in these sessions. But I would encourage you, if you look here, you have a lot of different heroes, different weapons. I encourage you to experiment, use different things. So for example, you have this staff here, right? You could, for example, instead of having a melee weapon, you can have a ranged weapons that shoots projectiles, whatnot. So you have fun, experiment. The more you experiment, the more you learn. You won't really be learning anything if you're just doing everything I'm doing step by step. So I encourage you to have fun with it. So thank you everybody for coming. I hope you enjoyed it. I hope you learned a lot. Sorry that it was a bit long, but yeah. Also, I'll be sharing with you the GitHub repository for the completed project, and the code is going to have comments, so you'll be able to follow that if you're confused about what is happening at any point. So I'll be sharing all these things with you. Okay, thank you everybody.
Thank you, Fouad. It was lovely. Thank you so much. It was really great. I hope all of you enjoyed the session. It was a little bit longer than usual, but I think that we learned a lot. And yeah, we'll see you all tomorrow or Friday, and have a lovely day, guys. Bye.